Homework number 11. Using the table shown below, calculate the following probabilities. What is the probability that we randomly select somebody who got pizza from the concession stand, given that they also got water? Okay. What do we call this kind of statement with this vertical line? It is given that, right? Does anybody remember? Is it conditional, compound? Conditional, because this is the new condition that we have to follow. We have to have water. So this vertical line becomes my horizontal line. And instead of the total, I put the total of the water, which is going to be what, class? 140. So we want all the water. That is your new denominator. So as soon as you see that vertical line, turn it into the horizontal line. Whatever follows it becomes your denominator. Got it? All right. Pizza. Of those people in this column who chose water and got water, how many of them also got pizza? 58. So my number here is 58 out of 140. That is your probability. Did anybody happen to have that before I did?
So you just
Good job, good job. Anybody else?
So you just find the total of the second.
If it is conditional, that means you will have this vertical line. Change that vertical line to the horizontal line. Whatever follows it becomes your denominator. So I look then at all water and people that got water. How many of those got pizza? It has to be in that column. Here's pizza and water, 58. Okay? All right, what is the probability that someone randomly selected from this table did not get a drink and they did get a hot dog? He's like, no, she's looking at me. Brian, you're looking at me. What do you think it is?
46.
Who said that? 46. That's my probability, right? 46. That is not a number between 0 and 1. I need a denominator.
400.
400. Oh, yeah.
She said it.
Yeah,
She just.
I heard her,
Okay.
but I was hoping other people would. All right, so no drink and a hot dog. No drink is right here. And a hot dog right here. Yes, and they both have to happen at the same time. That is 46. It doesn't have that vertical line, so the total is your denominator. Okay? Nupa, are you with me? Do you have anything out? All right. Number 2, a football coach has 3 quarterbacks, 6 wide receivers, 7 defensive linemen, and a kicker at practice today. Bet you didn't hear that today. One player got hurt. What is the probability that it was one of the quarterbacks?
3%.
3%. We usually deal with fractions. Although 3% would be a probability. 3 out of 16. How'd you get 16? You could turn it down. So, a football coach has 3 quarterbacks, 6 wide receivers, 7 defensive linemen, and a kicker at practice today. How many total is that?
Oh, kicker.
The kicker. You know why you forgot the kicker? They don't have one there. So yeah, you got to read and be careful. So I have a total of 17. Okay. What's the probability that it was one of his quarterbacks? Well, out of those 17, 3 of them are quarterbacks, so that would be 3/17. That is the probability that the one that got hurt was a quarterback. Questions on that? So be careful, make sure you read. Any questions on the Bellrick? How many more Bellricks do you guys have? 1 or 2? 2? 1? Is there one on the back too? No. So just 1, right? Oh, on the original. Okay. So 2. All right. So let's go to the notes. Oh my gosh. So I have this sinus drainage. I know you really all want to know this. You know?
Right.
Nose. Yeah. I don't know if it's allergies. I don't know. Independence. Now, we did talk about independence just a little bit, and that is the answer to number 2. That was the formula that we just wrote down, Joshua and Jennifer. Okay.
This page, really?
Yes, we did. I'm just going over. So if those 2 things multiply and give you the and statement, like probability of rain on Monday was 4/10, probability of rain on Tuesday was 2/10, the probability of rain on Monday and Tuesday was 0.08, is 0.4 times 0.2 give me that? Yes, it does. So look online, copy those notes, okay? All right, now let's get to this page. Probabilities of conditional and independent events. Here we go. We have 5 problems, and then we're going to call it a day. What day should we call it?
Okay.
Tuesday. Tuesday. That medication is really affecting you. All right, here we go. Find the probabilities. Find the probabilities. So we're going to flip a coin, ping, and we're going to roll a die. The coin lands heads up, and the die shows, let me get closer here so you can see, an even number. We're flipping a coin. The coin lands heads up. We're rolling a die, and the die shows an even number. How many different probabilities or blank spaces am I looking at?
5. I mean, is that 6 or 5? No, that's too slow. Wait.
4?
2.
2. Do I hear 3? 3. Anyone say 3? 3. 3.
Oh,
4.
you know how to do
4.
that?
4. 4. Do I hear 4? Sir in the back. 4.
okay.
4. 4. Sir. 4. No. 5. Anyone? 5. 4. Joshua. 2. 2. 2. You guys are guessing. 8? No. Listen carefully. Close your eyes. Just listen. You flip, close your eyes, I promise. I won't hurt you. You flip a coin. You flip a coin. You roll a 6-sided die. The coin lands heads up, and the die shows an even number. How many different events am I talking about? 2.
But
2.
I said 2.
After 6, 5, and 3, maybe.
No, I did not. I said 2 on the second one.
Did you fill it out? Okay, that's enough. All right, flipping a coin. So I want the probability of getting heads on a coin, and I want the probability of getting an even number on the die. So my coin, what is the probability? I need to sign it. 1/2. I usually have a pen up here. Does anybody got a pen? Okay, so the probability of flipping coin and getting heads, 1/2. packets are on the floor.
So easy.
Do you need 2 packets? Can you give him an extra one? A messed up one is better than no packet at all, or grab a packet from the back.
Ryan, what's your problem, like? I had that talk with you. You can start laughing.
All right. So, Dominique, I know it is sad. We should put our heads down, but we must persevere. So, heads is 1 out of 2. Even number. Nupa, you roll the die. What's the probability of getting an even number? Nupa.
Wait.
Shh, you're not Nupa. Yes, 3 out of 6. Please, where are your papers? Please just take them out. Okay, indulge me. 1 times 3. Quiet. Is 3. We're on page 13. And 2 times 6 is 12. If you give me this answer for probability, I will take that. And that will give you a positive. You won't miss any. But we can simplify this. I can divide both of these by 3 over 3 and get 1/4. So would you say these are independent events or are they dependent and conditional? Does the way I flip the coin, is that going to affect the way I roll the die and what I get on that? No. So those are independent events.
So will we have to identify it on the test?
I think maybe for some, yes.
Okay.
Don't hold me then. I haven't looked at it really recently. Sorry. All right. Number 2. There are 8 shirts in your closet. 4 are blue and 4 are green, thus the 8. You randomly select one to wear on Monday. You wear it. You randomly select a different shirt to wear on Tuesday. You end up wearing blue shirts on both days. So basically, they want to know what's the probability of wearing a blue shirt on Monday and a blue shirt on Tuesday. Now, you do not need to write that probability because when it comes to the test, you just have to find the probability. I'm writing that down so you understand what and the number of events we're talking about. So I'm talking about finding a probability for getting a blue shirt on Monday and a probability for getting a blue shirt on Tuesday. What do I have to have below my denominator? What is it? 16?
I agree.
How'd you get 16? So there are 8 shirts in your closet. Period. 4 are blue and 4 are green. So how many shirts do I have total in the closet? 8. Yeah, so be careful. Don't just start adding numbers because it says that, right? So I have 8 total. What's the probability of picking a blue shirt out on Monday? 4 out of 8. Okay? Now, I don't know all of you personally, but I'm hoping most days, although I know there are some days that, there's no laundry, not enough shirts, you got to wear same shirt twice. Maybe. I don't know. The shirt that you wore on Monday, you have already worn. You are not going to put it back up in the closet and hang it up. And you are not doing laundry on Monday night. So, how many shirts do I have to choose from for Tuesday?
8.
You wore a shirt, though.
Oh, 7.
Right. It's 1
Did
less.
he say,
No, we're not doing laundry.
No.
And you already wore it. It's going to go in the hamper.
Didn't he say he wore another blue shirt, though?
1 out of 7? Well, that is the question. We wore a blue shirt on Monday.
It's
So if I have 4 and I wore the first day, then it should be 3. Yes. Very good. Multiply these together. Top times top is 12. Bottom times bottom is 56. I would take this as a full credit answer, and if you told me and simplified it by 1, a form of 1, that would be 3/14. I would be ecstatic. Yes, 12 divided by 56. Any questions on 1 or 2? Now, is this, it says probabilities of conditional and independent. Are these independent events? No, because what you chose on the first one and wore affected the other one. So this is conditional. Conditional. Okay? And dependent. And dependent, not independent, dependent. All right, here we go. We're rolling on to number 3. You roll a fair 6-sided die twice, the same one, twice. First roll shows a 5. Second roll shows a 6. How many different probabilities am I looking at? 2. 2. My first probability is what you get on the first roll. What's the probability of getting a 5? What is it? 1 out of 6. Yes, because you have 1 5 out of all those 6 sides. Emily, are you with us? Okay. And what about the second roll? Dominique, come on. Sorry. My second roll, it shows a 6. What's the probability of getting a 6 on the second roll? 1? 1 out of 6. Yes, 1 out of 6. You have 6 sides, right? So 1 times 1 is 1. 6 times 6, 36. And that is in simplest form. Is that an independent events there, or are they dependent? Independent. Yeah, it doesn't matter what you roll the first time. It is not going to affect what you roll the second time. Independent events. Okay? Dayton, come on. Let's go. What? You are? With your head down? Does it make sense? Are you sure? Okay, because you know I'm going to bug you. I know. All right, a basket contains 5 apples and 7 peaches. You randomly select 1 piece of fruit and eat it. Oh.
Oh my God.
I really should be a comedian and have him in my audience at all times. Then you randomly select another piece of fruit. The first piece of fruit is an apple. And the second piece of fruit is a peach. How many different probabilities am I talking about? 2, says Avery. Ha, 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 ha. So, probability of an apple. Brian, what do I need to find the probability of an apple? What do I need to find to get the probability of getting an apple on my first pick? I don't know either. So that's why I asked you. How many pieces of fruit do I have all together in this nice basket? How many apples do we have? How many peaches? And so how many do I have total? 12. 5 plus 7 is 12. If that's my total, where does my total go in my probability? The bottom. The denominator. How many apples do I have again? 5. Where do I put the 5? On the top. Yes. So 5 out of 12. Oh my gosh. And then remember, I took a bite. How many pieces of fruit do I have left in the basket? Not 4.
No,
Did you say 4?
It's, she's
Not
still got
4.
12. You just took a bite.
We are not putting it back in the basket. 11. Yes. There are 11. Hey. No, it says, wait. I eat the whole thing. I said I took a bite, but it says you eat it. So I have 11 left, but in the second one, I'm trying to get a peach. What's the probability of getting a peach? 7. And remember, this is all theoretical. That doesn't mean I get an apple on the first pick and then I get a peach, but according to probability, that's what it should be. So multiply 5 times 7, 35, 12 times 11. I don't know, what is that? 122. Thank you. And I don't think I can simplify that. So that is simplest form. Are these independent events? Or did what I do to the first one affect the second one? Yeah, you ate the fruit. Yeah, so these are dependent events. They're not independent. Okay? Last one. You ready? Ready? Here we go. Here we go. Last one. Who haven't I talked to?
The last one for the day.
A and B, yeah. So in a game, you choose a card from a box containing 4 red, 6 blue. Guys, come on. This would go faster if people would stop talking. 4 red, 6 blue, and 5 yellow cards. You draw 1 card. You put it back. You put it back. Then you draw another card. What's the probability that the first draw you choose a red or blue card? Ooh, or. And the second draw you choose a blue or yellow.
Your denominator is 16, right?
How many probabilities do I have to consider?
2.
2. What is the probability of getting a red or blue?
4 over 16.
How'd you get 16? How'd you get 16?
We're not going to talk. If it's wrong, it's wrong.
How did he get 16? What should my total be?
The Adam wrong?
6 and 4 is 10, and 5 is 15. Now, if I get a red, if I get a red or a blue, that is a success. So how many successes can I have in trying to get a red or blue on my first draw? Red or blue? 10. Yes, because you have 4 reds and you have 6 blues. And there's nothing same about them, so we can't subtract something that was counted twice. And then we are going to draw a second time. What's the probability of getting a blue or yellow? First of all, I put the card back. How many cards do I have total to choose from now in this pile? 15. And what's the probability of getting blue or yellow, Mr. Avery? Blue or yellow? 11. Yes. So multiplying top times top, I get 110, all divided by 225. If you get this answer, you get it correct. If you give me the simplified version, that is also correct, which is going to be 22 out of 40. What is it? 42? 42? Somebody please take 225 divided by 5.
Okay.
45. 45, right? I think it's 45. Yes?
No,
Are these independent?
it's not 45.
Are these independent? When I draw that second time, is it just kind of like I drew the first time? Yeah, it didn't affect it. So these are independent. Does everybody understand how we get that? If you end up with the same number of cards in your total, that's probably meaning it's independent. Last one. This time you do not replace the first card before choosing the second card. What is the probability of choosing a blue card and then a yellow card? We still have the same cards. So how many different probabilities am I looking at?
1. Oh, 2.
2. The probability of B and the probability of yellow. How many cards do I have to choose from for the first draw?
14. You said you don't put the card back, right?
Well, but the first draw, I still have all 15, right?
Oh, I thought she was talking about some other problem.
Okay, and how many blues do I have?
6. I was looking at the wrong one.
Okay, now, after I draw that first card, I'm keeping it. How many cards do I have in the second draw? 1 less, which is 14. How many yellows, theoretically?
5.
I have 5. Multiply. 6 times 5 is 30. And 15 times 14, I think it's 210, if I remember. So divide by 30 over 30, you would get there eventually. And simplified reduced form is 1/7. Are these dependent or independent? Dependent, because what you did on the first one did affect the second one. All right, so what does this mean now? It means we're done with notes. Yay! This also means that you really need to finish homework number 4 on Canvas. Please listen. For homeworks 1 through 4, how many attempts do you get to get a highest score? It is 5. So if you've only tried once and you're not doing so hot, try it again. Okay? I'm sorry? Does it show the correct answer? No, you're supposed to put the correct answer in. In addition, I am giving you today the review. Okay? The review. Some of you are probably already done with homework number 4. I know somebody is in here, and they actually got 100%. So I'm going to give you the review. We are going to work on it in class tomorrow, and I will try to go over questions if you have questions. I would love to get through most of this so we can play a game of review on Thursday. Test is Friday. Yes. Yes, but I need to write a pass. So go towards the back. 1, 2, 3.
That's crazy.
1, 2, 3. Hey, guys. Hey, listen. Carmelo, come on. We have about, 7, 8 minutes? You work on this review, or you need to work on the homework number 4. You've been gone a lot, haven't you? Are you gonna be here? What's your last name? Hi, sir. Yes. Okay. All right, so we are going
So, how much?
No.
Thought she knew about
Have you started on some of them?
because they tried to kill me.
Or have you looked at any of the notes?
He's a
Or just as